Hello everyone, welcome back to the channel. This is BJ Tutor, and in this video let us try to solve question number 11. So students, let us read our question number 11, and it says, look at the following mastic pattern of squares. So they have given us a mastic pattern of square shape. Okay, and the question further says the squares are not separate. So as we can see from the figures that here in this figure number 2, that how many squares are there? Yes, there are 2 squares. And in figure number C, how many squares are there? 1, 2, 3, right? 3 squares are there. And in figure number D, how many squares are there? 4 squares are there. So all these squares, like in figure number B, figure number C, and figure number D, they are not separate, right? So that's why the question is saying the squares are not separate. Then it says 2 neighboring squares have a common mastic. So let's look at figure number B. We can see that how many squares are there? Yes, there are 2 squares. And between these 2 squares, there is a common mastic. Right, and again in figure number C, let's look at the first 2 squares. There is a common mastic. And again, when we look at the second and third square, there is also another common mastic. Okay, so the question is saying the squares are not separate, and 2 neighboring or 2 consecutive squares have a what? Yes, common mastic. And the question further says, observe the pattern and find the rule that gives the number of mastics in terms of number of squares. So the question is asking us to find the rule. Okay, to find the rule that gives us the number of mastics in terms of number of squares. Okay, so we are going to find the rule. And in the question, they have given us one hint on how to solve this question. And the hint says, if you remove the vertical stick at the end, you will get a pattern of C. Okay, it means that if we remove the vertical stick at the end, let's look at this first figure. Okay, if we remove the vertical stick at the end, means if we remove this mastic which is at the end, okay, then what do we get? We get a C-shaped figure, right? And again, if we look at this figure number B, and if we remove the last vertical stick, then what did we get? Yes, we get a C-shaped figure, right? There's one C, there's another C, like this. Okay, so this is a hint that the question has given to us. So let's try to solve this question. Okay, so students, these are the pattern of squares which are given the question. Okay, so before we solve this question, let us count how many mastics are required to make one square figure. Okay, so here to make this one square figure using mastic, how many mastics are required? 1, 2, 3, 4. 4 mastics are required, right? So 4. Then what about this, our figure number B? To make how many squares are there? 2 squares, right? So to make these 2 squares using mastics, how many mastics are required? Let's count. 1, 2, 3, 4, 5, 6, and 7. 7 mastics are required. And similarly, let's count the number of mastics required to make 3 squares. 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10 mastics are required. And we have another one. So to make how many squares are there? 4 squares. Let us count how many mastics are required. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Then 11, 12, and 13. 13 mastics are required. Right? So these are the required number of mastics to make those figures, square figures. Right? And in the question, they have given us one hint, right? And the hint is to remove the vertical stick at the end. So here, let us remove the vertical stick from this first figure. Then we get, what is this figure? Yes, we get a C-shaped figure, right? And to make this C-shaped figure, how many mastics are required? Only 1, 2, 3. 3 mastics are required, right? Then similarly, for figure number B, let us remove the vertical stick at the end. Then how many mastics are required to form 2 C-shaped figure? 1, 2, 3, 4, 5, and 6. Right? Then what about this one? Similarly, let us remove the vertical stick at the end. Then we get 3 C-shape, right? 1, 2, 3. And how many mastics are required? 1, 2, 3, 4, 5, 6, 7, 8, and 9 mastics are required. And for this one also, let us remove the vertical stick at the end. Then how many? Then we get a C-shape, right? How many C-shape figure are formed? 1, 2, 3, 4. And how many mastics are required? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, and 12 mastics are required. Right? So these are the number 3, 6, 9, 12. So if we observe these numbers 3, 6, 9, 12, what do we get? We come to know that 3, 6, 9, 12 make a table of 3, right? There is a multiplication table of 3. 3, 1 is 3, 3, 2 are 6, 3, 3 are 9, and 3, 4 are 12, right? So if we take the number of square form as a variable x, if the number of squares is taken to be a variable, so you can take any variable. So for me, let me take the variable x, right? Now if the number of square form is taken to be the variable x, then the general rule will be given by, remember, they are all the multiplication table of 3, right? So 3 times of number of squares, number of squares, okay, and plus, remember, we have removed one vertical stick from each figure, right? So we have to add that one also, plus 1. Then it means 3 times, what is the number of squares we have taken to be? Yes, the variable x. So 3 times of x plus 1. That is, we will get 3x plus 1. So the general rule for finding the number of squares in terms of number of mastics will be given by 3x plus 1. Understood, student? So let us check whether this general rule 3x plus 1 is correct or not. Let us check. Okay, so let us check whether this given rule 3x plus 1, the rule that we get just now, is correct or not. Okay, let us check. So yeah, let us add this vertical stick that we have just removed, and let's check whether our formula is correct or not. 3x plus 1, whether our formula 3x plus 1 is correct or not. 3x plus 1. Okay, so let us check. So let us check from this first figure. We all know that to form one square shape using mastic, the required number of mastic is what? Yes, 4. So let us check whether this formula 3x plus 1, that is our answer, is correct or not. Remember, x denotes the number of square, right? So 3 into, how many squares are formed here? Only 1. So 3 into 1 plus 1. What is 3 times 1? Yes, 3. 3 plus 1. What is the sum of 3 and 1? Yes, 4. We get the same value, right? Again, let us check for our second figure. Let us check. Remember, the formula is 3x plus 1. So here, how many squares are there? 1, 2. 2 squares are formed, right? So 3 times, so instead of x, we have to substitute. How many squares are formed here? 2. So 2 plus 1. So what is 3 times 2? Yes, 3 times 2 is 6 plus 1. And what is sum of 6 and 1? 7. So let us check whether our answer 7 is correct or not. Let's count the number of matchsticks here. 1, 2, 3, 4, 5, 6, and 7. So we have the same value, right? So like this, we will get the same value for this one also and for this one also. So our final answer will be 3x plus 1. Understood? Let's solve the next question. Next, our question number B, students. Here we have y is the shape. It has 3 sides. Yes, it is a triangle, right? So like in question number A, for like finding the general rule in question number A, for this also we have to find the general rule for the required number of matchsticks in terms of number of, yes, triangles. Okay, so first of all, before we solve this question, let us count how many matchsticks are required to form these triangles. So here in figure number A, how many triangles are there? Only one triangle. And how many matchsticks are required? Let's count. 1, 2, 3. 3 matchsticks are required. And here there are, how many triangles are there? Yes, 2 triangles are there. And how many matchsticks are required? 1, 2, 3, 4, and 5. 5 matchsticks are required. What about figure number C? How many triangles can you see? 1, 2, 3. Yes, there are 3 triangles, right? And let's count the required number of matchsticks. 1, 2, 3, 4, 5, 6, and 7. And last one, we have figure number D. Let's count the number of triangles first. 1, 2, 3, yes, 4 triangles. And the number of matchsticks required are 1, 2, 3, 4, 5, 6, 7, 8, and 9 matchsticks are required, right? So like in question number A, if you remove one vertical stick from the end, then what do we get? Instead of 3, if we remove one vertical stick from the end, we will get 2, right? Then this 5, if we remove one matchstick, we will get 4. From 7, if we remove one matchstick, we will get, yes, 6. And from 9, if we remove one matchstick, then we will get 8, right? So if you observe these numbers 2, 4, 6, 8, what do we know? Yes, we come to know that these numbers 2, 4, 6, 8 makes a table of 2, right? That is a multiplication table of 2. 2, 1 is 2, 2, 2 are 4, 2, 3 are 6, and 2, 4 are 8, right? So if we take number of, instead of square here, we have to write triangles, right? So if we take the number of triangles as, you can take any variable, okay? So for me, let me take the variable x. So if we take the number of triangles as x, then the general rule, the required general rule will be given by, since these numbers 2, 4, 6, 8 make a multiplication table of 2, so we will have 2 times number of triangle, right? 2 times number of triangle. And remember, we have removed one vertical matchstick from each triangle, right? So we have to add that one also, plus 1. Then we will get 2 times, instead of number of triangle, we have to substitute, yes, by x. 2 times of x plus 1. That is, our final answer will be 2x plus 1. So this is our required general rule. 2x plus 1. Understood, student? So let us check whether our general rule 2x plus 1 is correct or not. So let us check whether our general rule is correct or not. Let us check. Okay. In exam also, you can check in your working column whether your answer, that is your general rule, is correct or not. You can check. So let me tell you how to check. It's very simple, right? So our general rule is 2x plus 1. So let's look at the first figure. Here, how many triangles are formed? Only one, right? And how many mastics are required? 3 mastics are required, right? So let's check this one first. So 2 times, what does x represent? Yes, x represent number of triangles formed. So here only one triangle is formed, right? So 2 times of 1 plus 1. So 2 into 1 is 2, right? So what is sum of 2 and 1? 2 plus 1 is 3. So we have the same value, 3, 3. Right? Let's check another one. Let's check one more. So let us check for our next figure, figure number B. Right? How many triangles are formed? 2 triangles are formed, right? So 2 into, instead of x, we have to substitute by the number of triangles. That is 2 plus 1. So 2 times of 2 is, yes, 4. 4 plus 1. So what is 4 plus 1? 5. We have the same value. Right? So our general rule, 2x plus 1 is the correct answer. Understood then? So that's it for this video. I hope you all enjoyed the video. If you did, please don't forget to like and subscribe to my channel. And I will see you all in the next video. Stay safe, stay home everyone. Do take care.